Thank you very much, Mark. I'm hoping everybody can see me or my screen, or both, preferably. So as Mark said, I've been with HS2 since 2012, and I head up GIS at HS2. I work within the digital engineering team function. So today I was planning to, very similar to Rob, just give you a bit of a flavor of the project, then delve into our vision of a digital twin, how I see GIS contributing to that digital twin, our approach that we've taken to data quality at HS2, and some of the key challenges and opportunities this may offer both ourselves and our supply chain. So just delving into the project, and it would be a shame if the GIS lead at HS2 didn't have a map. So I thought I'd include one. Just talk through where we are at the moment. Effectively in 2017, received powers by Parliament to start construction. And since then, we've been taking enabling works, and Rob has covered some of that earlier, in terms of archaeological digs, the ecology surveys, utility and road diversions that we've had to put in place to effectively prepare the site for construction. This year in April, we received the notice to proceed, and we are heading off into construction at the moment. The section which runs from Birmingham up to Crewe, we call phase 2A, and that stage is we've deposited a hybrid bill in 2017, and we're following the parliamentary process at the moment in the House of Lords, and we're hoping to receive royal assent this year for phase 2A. Phase 2B is the bits running up to Manchester and Leeds, the orange bits over there, where we are beginning work on the parliamentary bill, the environmental impact assessment, and we'll follow then a very similar route to phase 1 and 2A in terms of the process through Parliament. So the current plans are for phase 1 to be operational between Curzon Street and London between 2029 and 2033, and for the full network to be operational and completed by 2040. Just want to touch on the three main kind of issues that HS2 is trying to address, and kind of setting out what we plan to do in terms of those. So in terms of the railway network at the moment, some people might argue, but it is getting overcrowded, so we desperately need more capacity. So HS2 will be effectively taking long distance trains off of it by creating thousands of extra seats and space for more local and commuter freight services. In addition to climate change and how the climate is changing, HS2 is looking to provide a low carbon alternative to long distance travel. Sorry, I'll just click that one. So the last one, which is probably geographer's dream, which is kind of where I was trained, is about the better connectivity that HS2 will enable. We do see there's in terms of the country, there's an unbalance between the north and the south, and this is about linking those cities together, but also driving up the economies. So moving from the physical, I'd like to talk a little bit more about the virtual and the digital version of the railway. Effectively at HS2, we've got 4 key building blocks to our digital twin, which is effectively our geographic information, our 3D geometric information, asset information, and related documentation for that. This will then obviously integrate with other data related to planning, program, health and safety, and so forth, so the list goes on. However, the overall aim that HS2 is committed to is using digital engineering to build a virtual railway during the design and construction phases of the project, with a view to then hand over a digital representation of that railway for operations and maintenance. So it's very much evolving from the design and construct stage to that point. The virtual railway will enable us to plan, design, verify, and validate our construction before we even start. As we go through construction, we will be installing sensors and devices that should enable us to get real-time feedback from the physical asset in our digital twin. And this will allow us to do real-time monitoring and performance management of the railway. In terms of the common data environment that we set up, we have taken both a centralized and a connected approach. In early stages, we've recognized that we need much more frequent exchange of information. So we've set up a centralized approach where our supply chain at that stage is working very closely with us as delivery partners effectively, because it's the fast-paced nature of the information flow between ourselves and the parliamentary process, as an example. So we've set the centralized version up to support that. Moving forward into the more main works contractor world and the enabling works, we have taken a slightly different approach in terms of a connected environment. And the key point about that is that we've actually, to create an environment for innovation and collaboration between main work contractors, we haven't stipulated what systems or software, more specifically the software that they have in place, but we have recognized that those 4 key elements are required to manage their information as well. So we have given them a lot of freedom in terms of actually the tools that they procure to effectively develop that virtual railway and then the end goal of the digital twin. Across that, we do have a visualization hub, which is our integration environment and is the basis that we're using to build up our digital twin. So from a GIS point of view, one of the things I wanted to touch on was, given all this digital twin, how do we see GIS fitting in, contributing to it? And the most obvious one to me is obviously the one that all the textbooks say, which is around using location as an integration and analytical framework. But what that means is actually it does then start supporting putting our railway and our virtual railway and digital twin within the context of the wider landscape. So it is a very visual way of actually communicating rather complex and disparate information about a single asset in our example. The second bit that I think is an area where the GIS industry has been quite good at is effectively transforming business processes, whether that be through remote sensing. Earlier, Rob was talking about the AI that was coming in terms of actually using aerial imagery and analyzing that further. But even down to the simple world of actually running surveys on mobile tablet devices, which are GPS enabled. And we're seeing more and more of this, where actually the technologies that have come out by default have a location element to them. So there's a massive area there in terms of the geospatial industry to contribute. The third area that I thought was an exciting area that I think we need to pay attention to, even though most of us kind of use it without thinking about it, is actually the work that the geospatial industry and other industries have done in terms of actually being data centric, putting data first and making sure that we do spend a lot of time taking care of the information that we're collecting to make sure that it's right for purpose. Secondly, the industry, the bit that I think a lot of people take for granted, things like web map services and these standards that encourage interoperability, part of that is actually not forgetting that it's there, and possibly taking very similar approaches and trying to understand what went well in those processes, to inform the work towards a digital engineering approach, in creating a digital twin to rely less on to actually make data more interoperable between systems. There are a host of other areas within the GIS area that actually do contribute quite heavily, and I think the industry has done a lot in terms of digitizing and automating processes by releasing value and improving data quality from the get-go. The industry also has a substantial amount of data models which describe the physical geography, not only of the country but of the world, and I think we should be looking to draw on some of those. So underpinning all of this virtual world and the digital twin, we have recognized that data, and we've done this for some time, that data quality is imperative to get right. So a piece of work that I've led on recently with an HS2 is developing a digital engineering data quality management framework, which is following and is aligned to ISO 8000 around the concept of continual improvement. And at HS2, we are setting out the processes that we think should be followed, the responsibilities of people that should be part of the data quality discussion. Strangely, that does mean everybody in the organization and the supply chain need to care about data quality, but there are very specific roles that we're starting to define to look at correcting information or getting information correct. In addition to that, we are pushing out supporting tools that will help us automate and validate that information as it's coming through. So very quickly, to just run through our continual improvement cycle, we are looking at the plan stage to set up those quality measures and quality expectations. We're then looking at the do box to effectively put in place data quality control, so at data entry, catch the error before it's created. We then need to check that information to make sure that the data quality assurance process has been followed, identifying any non-conformities or any issues with the process. And that then feeds into the ACT element, which is really about the root cause analysis of why we have that error in the data, and then making the changes in the planning stage again to make sure that we've got the correct quality measures, the correct processes, and whether any of them need to be improved. So as part of that, we're looking to embed the 3 dimensions of data quality that have been set out in ISO standard around readability, realism, relevance. And for us, the objective of doing that is to effectively help us with decision-making and driving efficiency. So it's really important to us, and I think it's about communicating that both within HS2, but also to our supply chain. So very quickly, readability is about how the data is structured, making sure that it's classified consistently. Realism, we need to make sure that it's accurate and comprehensive, but also more unambiguous and it needs to be meaningful for the end user. And then finally, relevance, which is covering usability and usefulness. So the data needs to be in date, needs to be accessible, and it needs to be available and secure to those that need access to it. As we move along that continuum between, it's not quite a continuum, but between readability, relevance, and realism relevance, readability is quite easy to do in terms of checking, whether things are codified correctly. It gets a little bit harder to automate some of that in terms of the realism relevance. So whether some things are unambiguous or whether it's useful becomes, it increasingly becomes more reliant on human beings to look at it rather than automation. So we do recognize that there's a range over there. I just wanted to summarize finally by setting out some of the challenges. I initially wrote challenges, and then I went, well, actually, these are opportunities as well. And These are not all of them. These are the main ones that we consider to be around. So whether we call the railway or construction traditional industry, there have been significant improvements in terms of actually transforming the industry through digital approaches, and we've heard some of that from Rob earlier. But there's still more to be done. There are loads of opportunities around digitally transforming how we operate. The next one is around the key challenges we're facing around a multi-vendor environment, where we're looking for data exchange and interoperability. And I did touch on that a little bit earlier. The GIS industry has made some headway in that, but there's more work to be done, and what we can do about furthering that data exchange interoperability conversation. As alluded to earlier, it's a massive project. It's extremely complex. The number of contracts and interfaces we've got on the project, between railway systems, the rolling stock, i.e. the trains that are going to be running on them, the customers. During design, there's the electrification that needs to be plumbed in. There's a whole bunch of elements to this where actually the digital space could help us around that. Finally, the last three, pretty much by being data-centric, we do have loads of opportunities around its integration, its exploitation, analysis, and visualization to effectively save that, to save the money at the end of the day by actually making better use of data. Focusing on data, and you're going to hear me say data a lot, means we're not that worried at this stage about technology. We're more focused on the data, because the railway will be running for approximately 120 years, over 120 years. And the technology that we have in place today will be very different to the technology we will have then. So we need to make sure that we get the data right now that we're collecting. And the last point I wanted to make was that very much there's a disconnect between the engineering processes for designing and constructing and potentially the digital engineering transformation that we're talking about, where the two conversations are slightly separate. And we see that as a potential challenge. That's more of a cultural shift in actually bringing our digital colleagues closer to our engineering colleagues. So on that note, thanks for listening, and I'll take any questions.